Okay, now we want to talk about the difference between AC and DC. So AC is going to stand for alternating current, and DC is going to stand for direct current. And so let's first talk about DC, direct current, because that's what we've basically been doing all along in here, is only been using DC electricity. So in the case of DC electricity, you're going to have a battery, and then we're going to run it through a resistor and then return it to the battery. And then, if you recall, we could measure the voltage on the resistor by using a voltmeter. So a voltmeter is symbolized like this, and then we could take the probes that come out of it and we go across the resistor to measure the voltage on that resistor. Now let's just say, for the sake of argument, that over here that this is a 1.5 volt battery. And then we take our voltmeter and we measure the voltage across the resistor. What's it going to be? 1.5 volts. And we could even get out a stopwatch. So we could make a graph of the voltage over here versus time. And then as soon as we click our stopwatch, we measure the voltage on the voltmeter, and it would turn out to be 1.5 volts. And then we could measure the voltage on the voltmeter 10 seconds later, and it would turn out to be 1.5 volts. So no matter how long you watch this thing, as long as there's juice in the battery, it's going to make something like this. So this is going to be direct current, DC, and the voltage is going to remain constant. Now eventually, however, the battery is going to run out of, it's going to use up its chemicals, and then what happens is this thing catastrophically drops like that. So that eventually it is going to run out of chemicals, and then the voltage is going to drop. But this represents what voltage is. Now we could also measure the current in this thing, and if you recall, the way that we would do that is we would open up the circuit, and then we would put an ammeter in there, and we could measure the current flowing through this resistor. And what we would find is we would get another graph over here, and then this one could be the current versus time, and it would be the same looking kind of graph, that it would be a straight line. So in a DC circuit, the voltage is going to be constant, and also the current is going to be constant in there. Now let's compare this to AC. So in the case of AC, we do not have a battery in there. So I haven't shown you this symbol here, but this thing represents a generator. So a generator is going to generate AC, alternating current. And then we could do the same thing. So again, we could have an ammeter in there if we want, and then we could have our resistor, and then we would have our voltmeter over here, and then we could be measuring the voltage across the resistor and then the current through the resistor. But this time we're going to get a different looking graph. So this time it's going to alternate. And in this particular example, the voltage is going to be 0 the second you turn on your stopwatch, but then the voltage is going to rise up to some maximum, and then it's going to decrease to some minimum, and then it's going to increase. So notice it has both positive voltages and it has negative voltages. Now it doesn't have to be this way, because depending on the circuit elements that you put in here, capacitors and inductors and resistors, when you start your stopwatch, it might start off with its maximum voltage, and then it's going to go down to its minimum. And so again, we could draw this like this, and I'm not going to finish out the picture there, but we can determine whether it's starting at its maximum or its minimum or somewhere in between by the correct choice of circuit elements in there. Now, what's interesting though about AC is that if we make a current versus time graph, okay, whenever this one is at its maximum, the current doesn't have to be at its maximum. So the current might be at its minimum whenever this one's at its maximum, or somewhere in between. So again, it depends on the circuit elements that you put in there as to if the current coincides with the voltage, or if the current is out of phase with this, meaning that whenever this one's at its maximum, the current is at its minimum. So we're not going to do anything with AC circuits in here, but if you go on to take more advanced physics classes, you would learn more about AC. And so again, if you want to watch those crash course episodes, they will talk about AC circuits in there. So I just want you to know, what does AC and DC, what do they look like as far as a graph is concerned? All right, now how do you make them? Okay, so traditionally you're going to make DC with a battery, and you're going to make AC with a generator. So we're going to talk about that later. It's going to be a machine that can generate an alternating current. Now we can, however, take AC current once it's been created, and by running it through different resistors and capacitors and inductors, we can turn AC into DC. So for example, in your computer, you know that your computer can run off of its battery, and you also know that your computer you can plug it into the wall socket so that it can run off of AC electricity, so that AC can be turned into DC, and DC can be turned into AC if you have the right equipment to go with it. So what are the advantages and disadvantages of AC and DC? So let's first talk about AC. In order to make AC, you need to have a generator. How would you like to carry a generator around in your pocket? So that's not going to be very practical. However, you can have very, very small batteries that are capable of producing DC electricity. So the advantage of DC is it's going to be portable. Okay, now what about the advantage of AC? Well, later we're going to find that you can change the voltage of AC electricity by using a transformer, so that you can have something at 10,000 volts, and then you run it through a transformer, and then that can lower the voltage to 220, which then can go into your house. Only AC electricity can be stepped up and down by using a transformer. You cannot do it with DC. Okay, this is going to be really important. So later we're going to talk about what a transformer is and how a transformer works, but just remember that only AC can be stepped up and down with the transformer. You cannot do that with DC, and that's going to be very important. All right, let's take a break. When we come back, we will talk about the electromagnetic force.